So good afternoon, everyone. Thank you all for attending this first afternoon. I'm truly pleased to see that the room is full. We might need extra chairs, which is a good sign. First of all, I would like to thank Professor Artur Silva for his presence here. Our Vice-Reitor will give us some words. I would like, obviously, to congratulate members from our research unit, RISCO, for being so participative and for replying very fastly to, obviously, to our query and participating actively in this event. So thank you, the enablers, thank you, RISCO members and collaborators, and thank you also, our advisory committee, for being here once more this year. We're in a lovely room, the Senate room here at the university, where you can see our former rectors. I hope that you will see some improvement from last year to this year. Hope so. We talked about this a little bit in our internal meeting this morning. And obviously greet our invited research unit CERIS in the name of Professor Dídia Covas, that we will interact more intensely today, because we'll have presentations from both sides, from researchers from CERIS and also from our research unit RISCO. So thank you all for being here today. Just very briefly to explain what is more or less the program for this afternoon and tomorrow morning. So after this opening session, we will have a session that basically will share ideas about our research interests. But before that, we'll have a formal presentation of our research units from CERIS. Dídia Covas now will do it on behalf of our part of RISCO. And then we will have a Q&A session where we can interact and talk about, I would say, future collaborations, fostering new ideas. How could the civil engineering field obviously reassess and reorganize its interests, taking into account the next decade? And then we'll have a network coffee break where you can have a look at our reposters. So they're divided by our main research areas, which is risk, sustainability, and conservation of the built environment. So then you can take a look there. We'll have a good half an hour for that part, so we can interact and talk and have coffee, okay? And then we'll sum up for the day around 5:45. So the program is not available physically, so you can scan what's behind the seats, okay, and take a look once in a while. On the second day, tomorrow morning, we'll continue actually with something that really went well last year, which was inviting other research units here from the UA, okay, from our, I would say, research ecosystem. And last year we had 3 research units. We had GovCop, we had Receção, and we had Intervenção. This edition we will have these 5 research units. Some of the coordinators will be with us and obviously sharing with us what they've been doing as a group. It's very interesting because actually last year there was some interaction with the other research groups inside UA, and I can tell you that late this month we'll have a joint event between Receção and RISCO about smart cables. So these things are very important because they foster and they'll help out and motivate the collaboration within the institution. Then we'll have another poster session, okay, a longer poster session where we can, because there's a lot of posters, and basically the posters were produced by our PhD students, so they will be the ones that will be by the e-posters, by the electronic screens to explain what they're doing, okay? And then we'll close off with some final remarks with the presence of our rector, Professor Ferreira, and then have lunch together. We're all invited to have lunch together tomorrow. Last year, let's take a look. What happened last year? It's a 1-minute video. Not much information, but obviously it's always nice to remember. So we have some other short videos. Maybe we can share them tomorrow at the closing session. But it was just to recall what was last year. So once again, thank you very much for your presence. And please, Professor Artur.
Well, boa tarde. Good afternoon for all of you. So I know the faces since last year. So welcome once again to the university. And I hope that you can spend here some days discussing what RISCO are doing and also preparing the new application for the next years. And also after these days that in the discussion with members and with PhD students, and so you can elaborate your report for that Romeu needs to put in the application. So this is important. But the most important aspect is that the room is full, as Romeu said, and that you can spend these days discussing, and because these events from each university is a way to put updated what you are doing and thinking in the future, because normally we are running our projects and so, but when we do some event like this, it's a way that we put in the presentation, in some discussion, and say in the poster, and PhD students say, well, I'm not in the good way, so I need, and this is the way also that I think the research units must do this workshop, these meetings, and having here the advisory board is also a way that you can discuss with strange people for you, and also having here the CERIS Dídia with us. We can see some information from them and also share what we are doing and see that in the future we can have some joint projects and so. So this is only 2 or 3 words to support the event, the meeting, because as I said, it's important to update what you are doing, discussing, because science is a way, it must be discussed face to face, because during the COVID we needed to discuss behind the screen, but nowadays it's important to have discussing face to face discussion between researchers, between PhD students and the supervisors, and also seeing the point of view of different people, different colleagues that can help to improve what we are doing. So it's this, and I wish you a very fruitful day today and tomorrow. I will stay only 5 minutes because at 2:30 I need to be in the habilitation. So, but I will look here some minutes, and then I wish you a very good afternoon. Thank you very much.
Apresentação primeiro da professora Dídia. Este, Covas, é aqui? Sim. Só por isto, porque eu não sei se a professora Dídia quer usar o passador de slides. Ok. Está sempre no último aqui. Não preciso micro. Não preciso som para eles. So moving forward with our program, we'll have two short presentations from CERIS, one from CERIS and one from RISCO. So I invite Dídia Covas, please, to present us the research unit.
Thank you very much. First of all, I would like to thank the opportunity to be here. I think it's always excellent to exchange our experiences, to better know each other, and to see in which way we can cooperate in the future. So, I'm the president of CERIS. I'd rather call it CERIS because it's the way we say it in Portuguese. Despite in English being series, I will always use CERIS because this is the way we use it in English. So what does it stand for? It stands for Civil Engineering, Research and Innovation for Sustainability. I'm still waiting for the pointer. Sorry for this. How have I organized this presentation? First of all, I'll present CERIS. How was it created? How is it composed of? How many researchers have we got? How are we organized? And then I'll give you some highlights of our results, of our activities. And starting with our creation. So our research unit is a research unit of the Department of Civil Engineering, Architecture and Georesources of Instituto Superior Técnico of the University of Lisbon. It was created in 2015 through the fusion of three existing research units in our department. It was, the first one was CEIDRO, the one from hydraulics and water resources. The other one was CESUR, the Center of Urban and Regional Systems. And the last one was ICIST, which was the Center of Structural Engineering, Territory and Construction. And why have we done this? Because we wanted to have a very broad thematic coverage of the civil engineering, and we wanted to establish bridges and synergies between each other and put all people working together. So we have created this center aiming at being having more synergies in the built and net. Okay. So what was the mission? We established the mission. Now we will revisit the terms in which we have defined this, but what was the mission originally? It was to create and disseminate scientific knowledge and also to transfer it to the society. It's not just to develop it inside, but it's also to transfer it to the industry. And the second objective was to enhance higher education and research training at the level of the doctoral programs. So we have several objectives, as I said, to promote leading-edge research through research project structures. And the activities that we developed are cross-cut by 4 thematic strands. Originally, we didn't have thematic strands. This was a requirement in the last call of FCT. We had to create them and to show that we were working around these 4 lines of research. And basically these lines are, first one, product development in civil engineering, second one, risk and safety, the third one, rehabilitation, and the last one, response to natural and societal changes, all around civil engineering area. This is just to show you the coordinating committee that includes all the parts, includes the executive board, myself. Then we have the 5 vice presidents. João Ferreira will join us and Inês Flor will join us. They might be arriving in a couple of minutes. Then we have the 4 thematic strands coordinators, the 4 coordinators of the research groups, and the hubs coordinators. The hub from CERIS Nova, Professor Rodrigo Gonçalves, and Professor António Tadeu from CERIS Coimbra. And this is the coordinating committee, which is a committee that meets. It doesn't meet with the frequency that the executive board meets, that we meet every other week. We meet every 3 months to discuss strategic issues and to take these strategic decisions. We also have a very important management group, which is coordinated by Evelina Rodrigues, our science manager, and we have 4 thematic strands managers that give support to the management of our research center. It would be impossible to manage 350 people without these researchers, because they are researchers, they have PhD degrees giving us support. So basically, Evelina searches for calls at an international level and national level, helps the researchers on preparing the applications, and coordinates the group of thematic strands managers. Thematic strand managers are researchers, as I said, hired through the programmatic funding from SCT that our research unit has received, and they give assistance to the thematic strands, to the projects. They help prepare applications to projects. They help in other management activities, and they give support to the management board whenever necessary. I would say this is almost the driving force of our series, what keeps us. Them together with our administrative, which is Ana Soares, they are very, very important in search. Then the research groups. As I've told you very briefly, we've got the 6 research groups. The first 2 related to hydraulics and environmental and water resources. The third one is systems and management. The 4th, transportation systems. The 5th, studies on construction. And the 6th, structures and geotechnics. And we are organized, as I said, members and collaborators and students and grant holders, and each of us belongs to one single research group. They have different sizes. The largest one is the one from studies in construction, whereas these are more or less the same size. The second largest one is structures and geotechnics. Then we have the 4 thematic strands. These thematic strands were thought when we applied for the last FCT funded, and these were the best way we could define our research. Nowadays, we believe that we have to revisit these thematic strands and eventually replace some of them by other concerns of our society, such as climate changes or digital transformation or concerns with energy. And we need to revisit this. And we will create a task force inside CERIS to start to think about this, how to organize, how do we want to present our research in the next application. So this is what we are currently. These thematic strands cross-cut the research in the six research groups. I would say that myself, I'm not just focused in one of them, I'm split among one or two thematic strands. For instance, my research is very much focused on risk and safety, but I also work in response to societal changes, whereas the other research is the same way. And then we have our experimental and computational labs that give support to our applied and fundamental research. We have 5 experimental labs: the Laboratory of Structures and Strengths of Materials, Laboratory of Hydraulics and Water Resources and Environment, Laboratory of Geotechnics, Laboratory of Construction, Laboratory of Transports and Infrastructures. Probably you know them, you have visited them. You're very welcome to come there and visit, and we can show you and we can share our facilities with our colleagues, naturally. And then we have the computational mechanics lab that has got servers and gives support to the numerical modeling in our center. Last year, we have created 2 hubs of CERIS. The first one is Nova Hub. Actually, Nova Hub, the researchers that belong to Nova Hub, they were already, most of them, in CERIS. They were already CERIS members and CERIS collaborators. But because they represented a significant critical mass, which is around 25 people, more than almost 30 people, we found it was fair to create this hub in Nova School of Science and Technology. And so they were created in February 2022, and Rodrigo Gonçalves is now the the president of this hub, or the coordinator of this hub. We also have another hub in Coimbra. This hub was created in April, 2 months later, and we believed that this partnership with them allowed us to reinforce the connection with industry, because they do lots of with applied research and consultancy with the industry. They have extraordinary laboratory facilities, they have space, they have different installations and equipment from ours, completely different from ours, because they have much more space. You can see the space here in Coimbra. Itecons has got all this. And so we decided to create an hub with 21 members and 2 collaborators in April last year. So basically this is what we are now. What have we done in the last 4 years? We have collected these numbers, that's why it's easy to show you the evolution of what we are now. Starting with theses. This is the evolution of concluded PhD theses in CERIS. On average, in the last 2 years, we have 39 PhD theses concluded. And during the 4 years, we supervised almost 400 PhD theses. Only 177 were concluded because the other ones are ongoing theses. Most of the theses were in civil engineering doctoral program because we had 4 FCT funded doctoral programs in CERIS that allowed us to fund lots of grant holders during the last 6 years. And these programs were divided between civil engineering. In civil engineering we had 2, one in hydraulics, another one in structures, transportation systems, and then also we supervise students in environmental engineering and etc. But most of the students are in civil engineering, transportation systems, and this represents almost 3/4 of our concluded PhD theses. And also, most of our PhD theses are developed at IST University of Lisbon. However, we have other joint collaborations with EPFL and with other universities in Brazil, Italy, and in other countries. But most of them are from IST. We have also developed competitive and competitive research projects. And this is the evolution in terms of number of ongoing research projects. We have international funding and national funding. Looking just at the last 2 years, just to have the big picture, I would say 1/3 of the funding comes from international sources, whereas 2/3 is from national sources, most of them from FCT, but also from ANI, PRR, and etc. And in terms of numbers, we felt the effect of COVID. These projects brought around 1.4 million. Last year, it was a very good year, 2.3 million euros that entered into CERIS. Overall, this is the funding in the 4 years. In terms of results, because our research is measured by metrics, and one of the metrics is publications in quartile 1 and 2 journals, and we have been growing a long time. We were created in 2015, so you can see the evolution. This is normal. The more we publish, the more citations we get, and the more we tend to publish even more. So this has been growing, and it has been growing as well, the publication in the top ranked journals. And I would say that on average we have been published in the last 2 years about 450 papers in this Easy Web of Science and Scopus journals. Our publications, we have relevant publications that are highly recognized internationally recognized, and we have some recognition. Just to show some numbers, we have 2 papers in the last 4 years that were among the first most cited. We have 15 highly cited in the top 1%. We have 2 hot papers in the top 0.1%. But we have also many papers with overdone 100 citations. In terms of other results of other outreach in our center, we have participated in the organization of conferences, which is normal, reference conference, worldwide conferences with over than 1,000 of participants. This is just some examples of conferences. CERIS members also belong to several editorial boards of national and international journals. Sometimes it's difficult to count the numbers, but we can say more or less over than 100 participations in these boards. And also CERIS members and collaborators also participated in a wide range of institutions and regulatory boards relevant to science. CERIS has made a significant effort to establish synergies with industry so that the research, the fundamental and the applied research, as I've said, is transferred to industry and to the society. So it is actively engaged in the Portuguese Technological Platform for Construction, in the Water Partnership, and in other clusters. And it has developed several outputs among products and prototypes, new materials, software applications, and has registered 5 patents as well. In terms of consultancy activity, so we develop research, but we also do consultancy work. And this is a significant part of our funding. We have raised in the last 2 years around 780,000 euros in consultancy. This allows us to be connected to the industry, to the needs of the industry, and also funds our research, funds our grant holders, funds our experimental and computational facilities, and is also a significant contribution for the income of CERIS and for keeping research active. And we also make an effort to transfer this to the professionals through the involvement in different professional courses through Fundec. Fundec is an association from Instituto Superior Técnico. That is, most of the participants in Fundec are members of CERIS, and we give short-term courses, professional courses at the professional level. And this goes, and these courses are not only given at the national level, but also at the international, to Angola, Mozambique, Brazil. It's a broad-ranging courses. We have also participated in other relevant actions. This is some examples. We have participated in the establishment of national legislation, in international standards. You have here some examples. And also, CERIS members have served in relevant positions in different associations. For instance, we have the president of the European Water Association, the president of the International Association for Bridge and Structural Engineering, and the member of Executive Committee of the European Association and Earthquake Engineering. We have received awards and distinctions. This is some examples of awards at different levels. In total, we received 74 awards and distinctions in the last 4 years. This is just some examples of awards from people that probably you well know. In terms of funding, this is important. I decided to bring it here. Our funding from the FCT, CERIS had 2 types of funding, a strategic funding and a programmatic funding. The strategic is the annual funding for keeping the research active and ongoing. This is a specific funding for human resources and for equipment. So overall, we have received from FCT, through the application that we did 5 years ago, around 3 million euros. Then we got plus 3.4 million euros in FCT projects, and then we have other sources of funding at the national and international level, and also consultancy. So we raised a lot of money in consultancy. Overall, in the last 4 years, it was around 10 million euros. But out of these 10 million, we have 2 million in consultancy. This is important because this is a very important source of funding of our research. And at the end of the day, we try to enroll ourselves in activities that respond to these United Nations Sustainable Development Goals. We are willing to establish new collaborations with other researchers, with other research centers. We want to attract talent to our group, to our research center, because we very much believe that the innovation, new ideas, and putting one step forward is through new blood, new people that we can join to our group. And this is basically who we are. Okay? Thank you.
Yeah, we are ahead of time,
Yeah.
but
We'll leave questions for the maybe
At the end.
at the end.
Não sei se precisa disto.
So, não, depois agora compensar o tempo.
Tá bem. Não precisa. Okay, so I'll try to make up for some from some lost time. So I'll basically be doing the same type of presentation as colleague Dídia Covas did. So as a coordinator, present coordinator of the RISCO research unit, I divided this presentation in 4 topics to get to know who we are, our scope and strategy, our research, main research lines, some numbers on our research outputs and scientific outputs, and some indicators for the future. So who are we? We're a small research group. We have 23 integrated members, but we have over more than 40 collaborators. So these are PhD students and doctors. So we're actually in a very interesting ecosystem, I would say, here at the university, where we have 16 departments and we have another 4 polytechnic schools. And we have here an environment of 20 research units, okay? All of them have been rated very good or excellent. This ecosystem is very interesting because we have the opportunity to interact and have an interdisciplinary nature. And as I said in my first intervention, last year we had 3 research units here, and this year we will have the participation tomorrow morning of another 5 research units. These research units obviously have some research fields of common interest, and that's why this is also important in this event to bring, even though we're in the same house, we don't know each other all the time. So the idea here is to continue with this strategy of internal dissemination and trying to interact more actively with other research units inside the University of Aveiro. Our RISCO unit is the civil engineering department. I would say that the civil engineering department is kind of like our nest, okay? It was created in 1996. We have a doctoral program in civil engineering. We have a doctoral program that we were involved in that we will finish this year, the InfraRISC program. That also one of the consortium partners was also the Technical University of Lisbon. We have a bachelor and master degree in civil engineering and a master in built heritage conservation. We have about all together PhD students and master students, about 200 students and researchers. We have 16 teachers, and we have a number of 7 staff members, administrative and technical. The technical in terms of lab. So just to give you an overall idea of how we were created, we started formally actually our activity in January 2015, then got reevaluated in March, and we had we had a slow start on the execution of our budget. But 2 things are very important here. We have to prepare an additional application for a budget for 2024, and in the last trimester of this year, we will be reassessed Next month we will have this. We'll have to prepare this additional budget, and in the last trimester prepare our reassessment. Our external scientific advisory committee is here today. I won't be presenting them. You've had lunch with some of them, so it's a pleasure to have you back. It was very interesting our meeting this morning because of the recommendations given, and I think as you said this morning, and I retain this phrase, that you're coaching a good student. So RISCO research unit is a good student, and it's easy to coach good students, like good PhD students, right? As I said, we're over 60. So we have a good percentage of women in our group. We have 30 active PhD students, actually a bit more, but these are the active ones that we keep a trace of, and we know that are working and are supervised by RISCO members. We had a pickup on the PhDs that were concluded in 2022. You can see there were 5 of them concluded last year, and there was this first trimester we had another PhD concluded. And very interesting to see that our students, our PhD students, are mostly foreign students. This is something that obviously I think is common in other PhD programs. One thing that we also looked into this year was try to understand and look up and see where our former PhD students are, okay? And it was very interesting to understand, and I only got that period between 2014, 2020, and 2022, 39 PhDs, because this was when RISCO started formally its activity in 2015. So we got only that period. It's interesting to see that we still have people, obviously, that are still integrated into research institutes, and some of them are in academic positions abroad. So, and then we have obviously a very high percentage going back to the industry, which is important because they're qualified, very, very well qualified engineers. We have our website. You can look up all our information. We have all the annual reports from the previous years. We have information on all of our members that we update every year. And you can also take a look at our indicator reports. We'll see 2 or 3 indicators in a moment. But we always have these 2 annual reports. One, which is the indicator report. So number of projects, number of PhDs, number of papers. And a second that will give you an overview of what was our activity last year and what is our plan for the present year. We also obviously disseminate, we have other channels of dissemination, I would say. RISCO Info, which is a newsletter we created that comes out twice a year. And RISCO Talks, which is basically a label that we give to our workshops and to talks of invited members and invited teachers from abroad and from other institutions. It's a way of obviously disseminating our research group. So other channels of dissemination, as I said, RISCO Talks. We also organize international events. We organized some international events last year, and we've got our newsletter. So budget-wise, just as Dídia told us, it's broken down into 2 strands or two streams would be a base and a programmatic. Just to stress that altogether, we, since the beginning, agreed on having a good investment in human resources, because that's where the production line is of papers. It's exactly in good human resources, in PhDs, students, and in PhD researchers. So we have a very good share, I would say a slice of our budget dedicated to human resource. Then we have another important slice dedicated to equipment that we bought. This equipment has obviously potentiated a lot of work with PhD students. You'll see some of the presentations from RISCO members, the use of that equipment to potentiate new areas of research and to help in the research programs of PhD students. And we also had 2 scholarships that were only attributed this year, in the beginning of this year, under the scope of our funding from FCT. So in terms of infrastructure, we have a heavy lab on the ground floor of the civil engineering part. We have a lab on the 2nd floor. We have a fire lab that's in another building it at the university campus, and we have open space rooms for obviously to have our PhD students and to have our grant holders. As also said, some of the integrated members of RISCO are in the boards of these associations, which is very important in terms network-wise. So we take advantage of this, obviously. And when we mapped out exactly who are we publishing with in this period, which is the period of evaluation, we see stronger links to some of these countries. So it's an interesting and important to understand where our members are mostly collaborating in terms of international cooperation. And these are the countries that have this more intense link. In respect to our scope and strategy, we have three main research areas, which is risk, sustainability, and conservation of the built environment. I would say that RISCO focuses, if we think about the impact on society, to promote and develop sustainable and resilient cities through safe, environmentally friendly, and efficient, durable construction infrastructure in various areas. I will not obviously read this, but it goes from obviously the development of new technology all the way down to smart transport and energy efficient sustainable mobility. So there's a lot of areas that obviously we work in and that go into these, I would say, these three strategic research areas: risk, sustainability, and conservation. These research lines or these strategic areas obviously link most strongly when we talk about risks to natural hazards, okay, and to anthropogenic hazards, also man-made hazards. And this is, we have a lot of, you'll see in a moment, a lot of scientific output in this particular research area. Then we have a second research area with sustainability in construction, where obviously a lot of work is being done on material science and on the use of the efficient use of natural resources, and obviously on the efficiency, energy efficiency, water efficiency, or water use, as well as this most recent problem, I would say, that had to do with housing and prefabrication and the need for more and durable housing. And the last area, which is the built heritage conservation, that's linked to obviously tackling problems of heritage loss, aging and degradation, obviously, of heritage values. So obviously we're always linking our areas and our fields to the SDGs, the Sustainable Development Goals, and I think that most of what we do in some areas as applied science is a lot of open science, a lot of citizen science, a lot of co-creation and sharing knowledge, and that we do a lot through obviously through consultancy services. I think that our research areas are aligned, you can see there, with what are the challenges or the present challenges today. Obviously, we have to always rethink because of these new calls. These calls more or less, I would say, mold the way that we look at our research lines, and we're always trying to understand this alignment between what are funding streams and what are our important research areas. In terms of scientific output, just let me give you some numbers, just like CERIS also gave us. So we have evolved over time. We have increased the number of members. We have more active national and international projects. We have more active PhD students, and more or less our number of journal publications. When I say journal publications, we're talking about article review type, or more or less stable. So where are we publishing in this period? Looking at where we're publishing obviously a lot in the field of engineering, but we have a lot of publications in the field of earth and planetary sciences, environmental science, material science, and energy. And in particular interesting, the social sciences, which is something that obviously comes into any type of call nowadays. Social sciences, the inclusiveness of the results and the way that that makes a better impact on society. So if we look at our numbers, we see that total numbers from 2018 to 2022 from Scopus and from the Web of Science are more or less stable. And when we divide this by the number of integrated members, which is 23, we have more or less three papers per capita, which is a good number. And obviously we don't want to go under this number because it's important to keep, as you said, numbers count. Everything that's countable should count, and sometimes things that don't count should be accountable for, but we know that numbers are numbers. A very interesting, another indicator that we looked into this year was to understand exactly, just looking at the Web of Science papers, where are we published in terms of journals with impact factor. So you can see it's very surprising and very interesting to see that we have published more or less 50% of our papers in 2021 in journals with an impact factor over 6, which is, over 4, which is very important. Obviously, we know that impact factors go up over time, but you can see that in this case, we have a very nice percentage of papers above an impact factor of 4. So obviously quality is important in terms of our scientific output. We talked about this also this morning. In terms of publications or share publications in Q1 and Q2 journals, we have around 86% of our publications are Q1 and Q2, which is a very nice number, obviously, in line with what we just saw in terms of the impact factor. And also looking at the share publications of RISCO in the top 10%, we have in this period 16.2% of our papers are in the top 10% most cited. Looking at the site score, not at other indicators like SNP or SJR, but 34.2% of our publications in that period are in the top 10% journals. And we have around 39% of our journals in that period that are co-authored by researchers from other countries, which is important because internationalization is something that obviously it is important for the future of a research unit. This was a very difficult, we do this every year, this is a very difficult cataloging of the papers, of these all of these papers that we had between 2020 and 2022. So we see most of our papers obviously focus a lot on this research area, which is the risks in the built environment. And looking at the prominence topics of Elsevier and from the SkiVal tool, we can see that there's some papers that actually, engage and interact these areas. So it's important for us to keep track of this because having 2 or 3 research lines, it's important that this is leveled out and we're always looking out for leveling and having the same impact in our 3 research areas. As you can see, we have conservation renovation that's going a little bit behind. So this is always important to look at and monitor over time where we are in terms of publications since we have our 3 research lines. Ongoing project and international national projects, just to give you an idea, we have 12 ongoing international projects and national projects. This is interesting just to show because we obviously, just like in other research groups that we've seen previously with CERIS, the budget that comes from the FCT is just a part. Obviously, the total budget by year can be like 5 to 6 times more, and that's what this represents. It's 5 to 6 times more per year than what we get from FCT. So we're not relying on FCT money, obviously, but it's important to say that we can generate, and that's important, much more than what we get from FCT by year. It's very important for us, the industry and public partners. We're in Aveiro, in a region that we have a lot of industry. We have to take a lot of potential out of this proximity within the industry. We do it with very big players, as you can see there. Others not so big players, but it's very important for us because it's another, obviously, another funding source, a very important funding source for us, and that represents the possibility of having more grant holders and obviously having the opportunity to innovate with, I would say, high TRL values in terms of technical readiness level products. So we want to continue growing, obviously, during this period with different stakeholders, with different research units. We have to obviously be aware of what are the current and future challenges. This is what will obviously make us stronger. Always having an outlook for what would be as Dídia said previously, if it's decarbonization, if it's digital transition, circular economy. There's so much out there that civil engineering field can obviously give to society, and continue obviously to engage with high quality and productive researchers inside the university and outside the university. So we have like a kind of list of musts, which is like something that obviously we should always have in, on our desktops or in my pocket, and read this like once a day or once a week at least, to recall that when we're coordinating a group, well, obviously we have to have a must list all the time. And my must list is more or less like this, because this must list is a must list that everyone in members of RISCO obviously agree on. It is something that we should read from time to time. I will not be reading it, but this is something that if we look out for these features and these points, I think that fact the rest is just is possible through working and collaborating. As I said, I'll basically finish off exactly as I started. We have to grow with impact, and the only way growing with impact is having more, obviously, very highly qualified and very, very engaged researchers. So we obviously, we're always looking for having researchers in these top calls. I can tell you that from year to year, we always have someone that's running for an ERC in our group. It's a small group, but even though it's a small group, we have always someone running for an ERC. We always have someone running for Marie Curie. So this is important for us, because there's ambition inside the group, and it's stimulating, obviously, for all of us. So that was very quick. I wanted to say much more stuff, but we have so many people to hear today, so thank you very much. I would basically, while we're switching computers, I would just like to say that but now in this panel where we have presentations given by researchers from CERIS and from RISCO, maybe you can start off with someone from CERIS, Mario, and then afterwards maybe you can have someone from RISCO coming in, okay, and then basically sandwich between. Oh, here's Silva. Okay, thank you.
So we will have, good afternoon everyone, so we will have these mixed presentations because the CERIS and RISCO coordinators behaved quite well and delayed 20 minutes the program. Both of them, and then the CERIS and RISCO researchers are going to behave even better and make it in 5 minutes what they have to say. And so keep your questions for the end, because the idea is this presentation should point out questions on you. Thank you, Maria.
Antes de mais, boa tarde. Embora os slides continuem em inglês, eu vou fazer a minha apresentação em português. Peço desculpa se houver algum transtorno com isso. A linha temática da linha temática 1 de desenvolvimento de produto nas indústrias de engenharia civil, a coordenação com a professora Dídia Covas referiu então a professora Fernando Branco. Eu sou o Mário Sá, investigador alocado a esta linha de temática. Temos como objetivos as áreas de investigação, as principais áreas de investigação e de output ou resultados principais, e os golos da Agenda 2030 e alguns exemplos de projetos de investigação e as nossas pessoas mais associadas, os nossos investigadores mais associados à linha temática. Como objetivo principal, temos então o desenvolvimento de uma investigação orientada no produto, no sentido de ser o mais lato, de forma a melhorar a competitividade das indústrias de engenharia civil, desenvolvendo então produtos e determinados procedimentos. Essas metodologias para alcançar esse objetivo principal passa então por uma forte ênfase na ideia de negócio de haver uma comercialização, uma potencialização um potencial de comercialização dos produtos nesse sentido mais lato. Tentando resolver então com soluções de problemas reais, envolvendo então os parceiros industriais, nomeadamente, como já foi referido, também da plataforma tecnológica portuguesa. Aqui um resumo das principais áreas de investigação, do desenvolvimento de diferentes materiais e produtos, com forte também destaque aqui nos materiais cimentícios duráveis de alto desempenho e ecoeficientes, a parte toda dos materiais compósitos avançados, quer na construção nova, quer na reabilitação, na parte também do desempenho sísmico das várias infraestruturas em termos de componentes e device e software, sistemas inteligentes, sensores também no que respeita também à própria segurança e a gestão e manutenção de procedimentos, o melhoramento de produtos e eficiência de projetos, incluindo então análise de custo desde o ciclo de vida, procedimentos de conflito de gestão e negociação, em áreas muito abrangentes, aqui resumida em 3 pontos. Os principais outputs, aqui divididos em 4 itens, que é dos produtos, com alguns exemplos, produtos e protótipos, que é da construção compósita, dos produtos de betão, soluções sísmicas, de hidráulica, os novos materiais, sobretudo os materiais reciclados, os pavimentos, nas soluções pavimentosas, mas também nas soluções hidráulicas. No terceiro item, nas soluções de software, de programas de software com comercialização ou não, mas em termos do dimensionamento de estruturas metálicas, estudos hidráulicos e também de comportamento ambiental e de gestão. E da parte também de soluções de ensaios especiais in situ e de construção de materiais, de solos e fundações. Aqui, pelo menos, a contribuição de 5 pontos de cumprimento da Agenda 2030, não prioridade, a parte da sustentabilidade das comunidades, da ação climática e das parcerias para atingir seus objetivos e toda o novo da indústria e inovação com as infraestruturas. Aqui, muito resumidamente, também projetos vários encaixados na TSI1, na linha temática 1, desde como ali o primeiro da previsão da vida útil de sistemas de gestão baseados no risco, e o professor Jorge Brito, ali 2 de Fireflow e o último relativamente à parte dos compósitos, painéis sólidos, o comportamento ao fogo, o último de biocompósitos, com PIs do professor João Romeu Ferreira, que estão desenvolvidos materiais compósitos, ali o projeto Shelter, com o PI do professor João Ferreira, que está aqui, relativamente a elementos hiperresistentes para mitigação do risco sísmico, e do PET das paredes de eficiência da professora Inês Flores Cola. Vários financiamentos, desde valores de 50 mil a 100 mil, 200 mil e mais. A nossa distribuição ali pelos quartis, de 25 a 50 e 50 a 75, ali marcado o terceiro e quarto quartil das pessoas associadas a esta linha temática 1, que ali no total faz cerca de 94. Por fim, só indicar algumas próximas atividades, sobretudo ali a primeira da disseminação dos principais resultados à indústria e todos os envolvidos na indústria da construção, engenheiros, arquitetos, designers e, sobretudo, em público em geral, que era pelo próprio site, uma coisa que vai sair agora recentemente, dessa várias dos principais resultados com potencial de comercialização, quer no próprio site do CERIS, das mailing lists e, sobretudo, nas redes sociais e mesmo das próprias redes sociais por via institucional do técnico. Apresentação de protótipos, protótipos e exemplos em feiras ou exibições relacionadas com os determinados projetos, âmbitos, como já foi no FICA deste ano, do ano passado, 2022, e agora mais recente, em breve, do Dia Aberto. Promoção também de webinars, juntamente com as outras linhas temáticas, e então uma interação de suporte entre os vários investigadores para criar essas novas sinergias entre os próprios RGs dos grupos de investigação. Pronto, e penso que tem sido rápido, está bem? Obrigado.
We will have questions in the end, because it's products. It's one of our researchers that is working on materials and products also. So we'll try to make here some kind of matching in the same field or parallel to that. 5 minutes.
I will try to be fast, as fast as I can.
Technician.
Okay, so good afternoon, everyone. I will talk briefly. I should talk briefly about a little bit waste valorization, new materials, and 3D printing. It's a little bit of everything, but I will start by recall my presentation from last year when I start my tenure at RISCO, and I have identified what will be the 3 main drivers of my work and my research. And the three drivers was use what you have, spend your resource wisely, and collaborate with others. So why it's important to use what you have available? Because local resources and local raw materials more or less equate to sustainable building materials. It's not as straightforward as that, but there is a considerable nexus between the transport distance, between the raw materials and the environmental profile of the end of product for the construction. So, as that being said, I have identified what were the relevant industries in our regional and national context that I want to work with it. So, paper and pulp production are obviously very important in central of Portugal and specifically here in Aveiro. The ceramic industry as well, and also the ornamental stone sector is very relevant national-wise. So these were the industrial sectors, and we look at the production lines of these sectors and identify several waste streams that will be interesting for valorize as construction materials. So this was the list of secondary resources that we target from this year's work. And as already have been said, it's important to have the industry with us so we can transfer what we achieve to the society and give back the investment that is making in our research. So we have the Navigator company as support us with the wastes from paper production, the Motor MES from the ceramic industry, and the Barmat as a mining and processing stone company. So for the second driver was to spend our resource wisely. So we wanted to use technology that is efficient, that is sustainable, and that is applied to the material design level. And we have been working with low clinker cements and also alkali activated materials. We have developed different formulations using the wastes that we identify as fillers, as supplementary cementitious materials, as precursors for alkali activated materials. And this also applied to the product manufacturing level. And we select additive manufacturing and 3D printing particularly as the production technology that we want to research and investigate it. And we acquired a medium-sized 3D printer, and we have been working with ever since. So, having identified what materials you want to valorize and the technologies that we want to use, we set up a mid-term plan. So we have more or less a guideline to our research. So the first step was to master the 3D printing technology that was new to us. So design new materials, investigate the rheological properties of these materials, control the studability, the buildability, the workability retention, start to print some simple objects, and then improve the quality of the printed objects, the geometric conformity, the accuracy, the finishing quality. And then once we master this, we want to steer what we find to two different market segments, to the heritage and building conservation segment, and to the new building elements. So there are different colors in that. The green ones means the topics that we already have working with. The yellow ones that are in this part is planning to be deployed during the next years, and the red ones will be for the future later down the road. Of course, setting a plan like this, it cannot be a one-man show. It needs to work with other people, and that leaves us with the third driver, that is collaborate with others. With others, I mean with other RISCO researchers, but also with external research units and universities. So in order to show that, I will show some of the work that we did in which we engage with other institutions. So the first one was the development of alkali-activated materials from local clays that are not useful for typical applications in the ceramic industry. So this was a work in collaboration with some undergraduate students and also with the collaboration with the University of Padua, in which we thermally treated the clays, identify what the mineralogical phases that were created, and then functionalize the materials into construction materials. In 2022, we did some basic characterization tests, compressive strength, apparent density, and so forth, so on. and this work will be extended throughout 2023. So we investigate the fresh properties and eventually go to 3D printing if the materials correspond as we wish them. The second work that I want to mention is the development of low clinker cements. And here we try a different approach than what is typical. We look at other research fields that we use multivariate analysis, principal component analysis, and then we work with the University of Padova to try to develop new mixtures based on a statistical analysis. Once again, we keep ourselves to very simple properties that are fast to measure and quickly to get an idea if the models are responding or not. But the overall concept is to prove that this approach works, and then we can apply this to the development of materials for the 3D printing. On top of that, we are working on in a more classical approach, that is perform rheological studies with different materials. We have engaged with partnership with different universities on different thematic projects for different wastes. So with the Maidra University, we work on biomass ashes because we have this a similar regional context, and they have available ashes over there. Agreed also with the University of Santa Catarina in Brazil, and also with the ornamental stone waste with CISECO, that is an internal collaboration here at the university level. So we have conducted some rheological experiments, as you can see here, and then do some tests to show the buildability, the sortability, how can we control the finishing quality, how many layers we can stack over each other without having collapse, as we showed us. You can see some improvements on the number of layers that we can build up. And then when we were satisfied with the number of layers that we can print, we start to modeling some very simple structures like cubes and try to replicate them with the cementitious materials and see the accuracy of the printing. If the cube that we model correspond to the cube that we print, and have to adjust the formulation so we improve the accuracy of the printed material, printed object. This was the first printed object that we did, but we want to steer this to the building heritage. So we are trying to engage with other colleagues here from RISCO, Hugo Rodrigues and Inês Bourgeois, and also undergraduate students, and also Prof. Vitor, to try to conceptualize how can we use this technology to replace or substitute some missing elements. But before starting to very complex structures, we want to show at conceptual level that it works. So we cut a cube there. We cut a cube, so there is a missing part. We model the part. So we build the missing part, then we print it, and then we see what were the best formulations to print this particular shape. Now the objective for the next years is to get more complex structures, and Inês is already working on the digitalization of these more complex elements. And once we are satisfied with the quality of the printing that we get, we want to go for more complex structures that for us has more higher value than a very simple structure like this. So of course that is just a conceptual demonstration of the concept that we want to put forward. So Inês will talk a little bit more about this, I guess, and my presentation is just that. Under 5 minutes.
Long 5 minutes. Two. We're going to give an award, go to the one that manages the fast 5 minutes. So we will mathematics 22, 2, yeah? Yes. Which is about risks. About risks. So,
Okay, good afternoon. Well, this is not very good because I am a short person. So good afternoon, everyone. My name is Marta Cabral. I am a PhD researcher at the Instituto Superior Técnico in the scope of hydraulics, and I am also the manager of Thematic Strand 2, which is coordinated by Professor Filipe Moura. So this thematic strand is about risk and safety in natural and built environments. So my presentation, I will start to talk about the main objectives, the main research areas, the type of research that are developed in these thematic strands, the contributions to sustainable development goals, some examples of projects that are developed in these thematic strands, the people that are associated to this thematic strand, and finally some next activities that we are planned. So the main objectives of this thematic strand is to address issues that are related to the assessment and management of the main risks that are associated with natural but also man-made hazards affecting built and natural environments. And this includes risk assessment of natural and man-made hazards, the engineering expertise for improving safety of people, of assets and of the environment, and finally the prevention, preparedness and management of risk considering the use of structural and non-structural measures. In terms of main research areas, the first one is developing innovative approaches, tools and solutions to answer the future challenge of the society, and this means for a better assessment, mitigation and communication of risks that are associated with natural and man-made hazards. The second main research area is developing safer, better dynamic performance and low maintenance infrastructures, and this includes from buildings and bridges to water and gas supply systems. And finally, the last main research area is planning of human activities and of research location to have more resilient communities developed in the built environment. So in terms of type of research, we can define 3 different types. So the first one is experimental studies that are carried out in civil engineering labs, and this includes since full-scale tests such as fire tests of composite beams to small-scale tests, namely local score of bridges, pillars, and also the floor dynamic of storage tanks. The second type of research is field measurements in real-life infrastructures, and this means seismic geographic tests, water quality tests, pressure transient tests in pumping and hydropower systems. These are just some examples. And finally, the last type of research is advanced numerical modeling, for example, the temperature flux in the composite beams, the calculation of moving loads in the railway tracks, and also of urban flood and tsunami propagation. This thematic strand is related to different and contributes to different sustainable development goals, but these 5 are the most important and the most related to. That is clean water and sanitation, sustainable cities and communities, climate actions, life below water and life on land. Some examples of the research projects that are developed under the thematic strand 2. The first project is an international one with the title of Platform for Atlantic Geohazard Risk Management, and it is coordinated by Professor Rui Carrilho Gomes. It is an ongoing project, and the aim of this project is to improve geohazard risk prevention and resilience to natural disasters in the Atlantic region. The second project is a national project that is and it was concluded last year. It is coordinated by Professor Dídia Covas with the title Improving Mixing in Storage Tanks for Safer Water Supply. And the aim of this project was to better understand flow dynamics inside water supply storage tanks, to find practical solutions to improve the design, the rehabilitation and the support of the operation of the existing tanks. Other two examples. The first one is the project, an ongoing project coordinated by Professor Fernando Branco and the researcher Mário Artur, with the title New Fireproof Dwellings for Wildfire. And the aim of that project is to protect new dwellings from wildfires using the concept of fireproof envelope facade with existing commercial non-combustible materials. And the last example is also a national project that was concluded in 2021, and it was coordinated by Professor Rita Bento with the title of Framework for Seismic Risk Reduction Resorting to Cost-Effective Retrofitting Solutions. Regarding the people that are associated to this thematic strand, so we have a lot of people that are somehow associated to this thematic strand. Above 76% we include more than 50 people. Then between 51 and 75% we have more than 10 people related to this thematic strand, and then with small percentage, but still with an influence in this thematic strand, we have between 150 people. Finally, regarding next activities for this thematic strand, and these are related to all the thematic strands. So we have the dissemination of the main results to industry, engineering, architects, designers, and also the correlation with the public sector entities. Then we have also the presentation of main research activities at fairs and at exhibitions in order to show the research that is carried out under this thematic strand. The promotion of webinars with different topics related to the thematic strand. And finally, the supporting interaction among researchers to create new synergy between academy and also industry. So thank you for your attention.
It's the first one in our work. Thank you.
Thank you.
And I'll call now two of our researchers. One first of all, so Paulo Material, that is also in charge of a big important group here in terms of risk, and not only, but he will.
Good afternoon. So maybe I can start speaking before. I decided to. Okay, so my presentation, the title is From Research to Solving Real Problems in the Field of Structural Fire Engineering. Some examples. I decided to design not to show results of applied or fundamental research, but the use of our knowledge to solve practical problems in situations that companies or design office don't have the knowledge to respond to their requests. So this will be 4 examples of consultancy, okay? And I will only focus on that. So a very, very, very short introduction. The last examples of the last 4 consultancy studies that we have done. I forget to say that it is, of course, not only my work, but with Nuno Lopes and also Carlos Couto, they have collaborated with these 4 in some of these 4 examples. The first one is composite steel and concrete structures for the pediatric wing of the Hospital de São João in Porto. The second one is the steel structure of the Montijo Airport. You know, it's one of the 9 possibilities that after 50 years that is on the table. The steel structures of the supporting of 1.6 kilometers of supporting solar panels over a motorway in Switzerland. And the last one, reinforced concrete beams of the Dakar Bridge in the port of Dakar, Atlantic in Morocco. So these are good examples. The last 4, because we have here the 3 types of construction: steel, concrete and composite steel in concrete. Examples of response of studies to design office out of Portugal, one in Switzerland, and another one in Morocco. So I guess this gives an idea of what we can do in the field of in my group, the structural fire safety engineer. So just to have an idea, what we need to do this type of studies or analysis, we have to define the fire scenario. So we have 4 steps. First one, define fire scenario. Second one, define the mechanical loading. Third one, the calculation of the temperature within the members of the structure. And last, to evaluate the mechanical behavior of the structure that has been exposed to the fire. So just to have an idea what type of fire scenario we can consider, in the left hand side we can see what we call prescriptive approach. If we use nominal fires that are very simple curves to define the heating resulting from the fire, and the second in the right hand side what we can call performance-based approach, which is using natural fires. The Eurocode 1 in part 1.2 of Eurocode 1 allows to use this type of natural fire. So, okay, this was the very short introduction. Now the 4 examples. This one is the doesn't work. No, the laser.
The laser is in the middle.
So this is the hospital of São João in Portugal, and this is the expansion for the pediatric area. So we have done the evaluation of the fire resistance for the standard fire curve. This is the nominal curve, one of the nominal curve, and the fire resistance needed was 2 hours. Here are the numerical simulation, and we took advantage of this member action that comes from the big deflection that in case of fire that happens. So there is a ring of compression zone in the periphery and a tension zone in the middle, and we can avoid to protect the secondary beams to allow to this big deflection. So we will see here some examples of what we have suggested for the protection. Here the black beams are not protected and the others are protected. The blues were protected to a critical temperature of 550 and the red one for 550 degrees C. So here is an example of numerical simulation for the temperature field in the slab after 2 hours of the standard fire curve exposure. The next one is the steel structures of Montijo Airport Terminal. Again, we needed fire resistance of 2 hours. And the fire scenario that we have used was the natural fire curve with a software that allows for 2-zone models. I will not go into details in localized fire. I just want to show the examples of what we have done and not enter into details. So here are the several scenarios there in several parts of the building, the main terminal, and here we have this is the main terminal, and there are 2 piers here that are linked to the main terminal by 2 bridges, and we have also studied this part of the airport. So here you can see the natural fire is a fire that with the increasing phase and the decreasing phase, and we have proved that in this case this is the still temperature doesn't reach the critical temperature. So examples where we have, so we don't protect any steel structure in the only zone that we have protected is this blue zone. So this is the example. The third example is this portal frame that is will be built in 1.6 kilometers and to support solar panels in this length of over this motorway. So again, we have used natural fire, and that was obtained with this software FPS. This was not made by us. It was evaluated by another company, and we just used the temperatures to evaluate the behavior of the steel structure. And the idea is that this structure doesn't collapse during all the phase of the fire. So what are the scenarios that they sent to us? A burning truck here in the middle, and a burning truck, a heavy burning truck close to the columns. So this is the temperature that we received from the company, and we use these temperatures to evaluate the behavior of the portal frame. This is one of the deformed shape of this portal frame, and we have proved that there are no collapse during all the phases of the fire. The last example is a bridge linking in Morocco, linking the port and the company. You can see here, this is the port, this is the bridge, and the bridge, each span is 25 meters, and because in this bridge there is this oil pipe here, the owner wants to ask us to evaluate the behavior of this beam here, the mass loaded beam due to the pipeline, and when submitted to a fire given by a hydrocarbon product. So what we have done is, this is the fire that they wanted to be used. In the first study, we considered a normal height concrete. Here are the fire scenarios: fire in 2 sides, 3 sides, 3 sides, and 4 sides. And later, we made this report, and they asked us to consider high strength concrete. And in this case, we should also consider the possibility of spalling. So, if you compare this, the cross sections here, you can see that there is a loss of cover, and the cross section was reduced due to this the detachment of the concrete. So, we have done, here is the temperature field. In the left side, we have the gross cross section here with the spalling, and with these two temperature simulations. Here is the deflection without spalling, and here with spalling. And we proved that we can reach a classification of 30 minutes of fire resistance with hydrocarbon fire. Okay, just to finish, what I have shown is we have used several different fire scenarios: the standard fire curve, the hydrocarbon curve, localized fires, natural fires, and also we have in these four examples several types of structures: steel structure, composite steel and concrete structures, and concrete structures. Here are the reference to our reports. And thank you very much.
Debate area. We'll go for another RISCO researcher that is in this field of risk. Vitor Silva is a principal researcher in Ferreira University.
Okay. Thank you very much. So in my presentation, which focus much more on risk, for example, on series would be on TS2, I believe. I tried to focus on three main lines of research that we've been doing here. And we were talking this morning about trying to find, the niche, the specific part that I think we can try to offer that other research units cannot offer. So we've been working a lot on basically building monitoring and machine learning. So basically trying to do risk assessment and vulnerability in a different way. Also using artificial intelligence for urban exposure modeling. I will show an application actually to Lisbon. But obviously a lot of this research is useful for all natural hazards, not just earthquakes. And then finally looking a little bit at the future, in particular in parts of cities a little bit more on the outside that are expanding, and how do we think the cities are going to look in the future. And this is obviously very much aligned with the 17 United Nations Development Goals. Just to go on the first trend, we partner with a company in California called Safe Hub. They have these new sensors. There's a few other companies in the world that also do this, but the sensors are very much low cost. They're quite cheap. You can install in anyone's houses, and they capture, for example, the ground shaking. But it does not have to be just focused on earthquake shaking. For example, we've been talking already about, for example, wind. And obviously, if we have information at the base of the building, we can do better risk assessment. But that part is actually not that disruptive, let's say. What we've been doing a lot is trying to assess actually at the top of the building. So every time that a building has damage, regardless if it's due to earthquakes or other causes, usually we have an elongation of the period because there's damage, there's loss, we lose some of the stiffness on the buildings, and we have verified this, for example, in the earthquake that happened in Spain. So if we see that there's an elongation of the period, there's some damage. But now let's try to establish a very good link between the different dynamic properties of the buildings and how much damage we expect on the buildings. And we have many of these sensors already in Portugal, and we're going to be installing in some critical facilities. We're going in May, actually, to the IST. I was talking with Dídia previously about this, because we will install 10 of these sensors in Lisbon. Because we will install in several places in Lisbon, then it's also possible for us to start to establish a network of sensors in addition to the sensors that already exist in the Portuguese networks in IPMA. And the goal is to establish a rapid loss assessment system. This has been already tested for a few places. But what we're trying to do is to understand really strategically where should we put the sensors, considering the seismic hazard, the vulnerability of the building stock, where do we have people with different conditions, for example, the older people, people with some disabilities, because these are the places where we need to understand where damage will be high. Moving now to this part about artificial intelligence. So every time that we do risk assessment, and actually this is not so much necessary for earthquakes, but actually for tsunamis or for flood, we need to understand where the buildings are located. And if you think about doing this at large scale, it's quite complicated for us to understand where the buildings are and also the structural attributes of the building. So using data from OpenStreetMap and also Google Street View, we built this framework that goes into specific neighborhoods in Portugal, and it just extracts directly all the images from the buildings. Then we hired some students, some master students. This is the neighborhood in Alvalade in Lisbon. They went building by building, they took photos, and they also classified the buildings according to the type of material of construction, the number of stories, irregularities, presence of basement. And with that information, we trained this artificial intelligence algorithm with 4,500 images. Then we gave it 500 images that the algorithm has never seen, and we asked it, can you classify now these buildings? The results were actually quite good. Quite surprisingly, we managed to classify correctly 85% of the buildings in this particular neighborhood in Alvalade, and we're now extending to Arieiro in the south. And this was quite interesting because we were having some conversations with the City Hall in Lisbon. They wanted to apply this now to the entire metro area because it's a way for us to get information building by building with a lot of information like structural attributes, which can be used not just for natural hazards, but they were proposing to use also for energy efficiency purposes to understand which buildings might need not just seismic retrofitting, but also improvements in terms of the energy efficiency. The last part is about future inequity and disaster risk assessment. This is actually something that different companies and also the Science Foundation in Portugal working on that. For this one is almost like a personal concern and something that I've been trying to learn more, and a few PhD students working on this. It's basically, we know that we're going to have a lot more buildings, a lot more people in the future. We just seen on the news that I think India now has more people than China, or it's very close for having something like that. And there's been some estimates, for example, from the World Bank, that everything that was built until 1970, if I'm not mistaken, will be built again in the next 3 decades. And we noticed that for some countries in Africa, like Nigeria and Egypt, the population is going to double, and so the building stock, so in the next 30 years. We did some experiments for some places that are expanding quite a lot in Portugal. This is in a small municipality within Setúbal, also in the south-ish of Portugal. But what we did was to use satellite images since 1974 and also look how the population has increased, GDP per capita, the urban planning, how that has increased until 2020. And then we use agent-based model to try to predict where people are expected to settle for until 2050. And we also try to use different risk mitigation strategies, now very much connected to earthquakes, but it could be also connected to other natural hazards. So, for example, the blue line that you see over there is the current risk trend for this particular municipality in Setúbal. And the gray line is basically, if I'm not mistaken, if you retrofit 1% of the buildings, I think every 5 years, if I'm not mistaken, we could lower the seismic risk. So it's not just about guessing how much the seismic risk can reduce or is expected to increase in the future, but we were talking also this morning about well-being and the fact that people now live longer. For example, in Portugal right now, the most common, let's say, age range, I think, is between 45 years and 49 years old. But in 2050, it's going to be between 80 and 84 years old. And if you imagine, if there's an earthquake, for example, in Lisbon, the people that will require assistance is very different from 2020 and 2050, if you think about people with disabilities. We actually asked the National Institute of Statistics in Portugal to give us information about the population age versus seismic provision, so basically the age of the building and construction material. And we noticed that there's a correlation between a person, let's say the occupants being older, and also the building being older. And these are the parts of the population that will need more assistance, and also some disabilities, people with difficulty in communicating or going up the stairs, living in older buildings. This is also usually quite common because basically some of these buildings are cheaper and the financial resources of those people are also lower. This is my last slide, so just to show the 3 trends. It's trying to use new technologies to do some stuff that is already being done, but trying to optimize this. Also using machine learning and artificial intelligence to build exposure models that can be used for different natural hazards. And then thinking about the future, how the cities will look in the future, and to make sure that when we produce risk information for risk reduction, that is adequate not just for today, but how we expect the cities to look like in 30 years. Thank you very much.
So we'll go back to Mathematics Fund 3, I suppose, conservation. Thank you. DECivil.
Okay, good afternoon everyone. Thanks again for having us in this meeting. I'm Adnan Kurici, working as a PhD researcher at CERIS and working in hydraulics and water resources, and also managing this thematic strand. Call it rehabilitation of built and natural environments. The coordinator of this thematic strand is Professor Jorge de Brito, and I'm supporting him. I will try to cover briefly about some main information about these thematic strands, starting from objectives, main research areas, type of research developed within these thematic strands, contribution in sustainable development goals, some research projects, people involved in these thematic strands, and some future and ongoing activities. The main objective of research developed within this thematic strand is to reduce risk, improve safety, and promote more efficient life cycle management of built and natural environment, also to foster urban cohesion and heritage protection. Specifically, this thematic strand aims to enhance the spatial functionality, energy efficiency, and the structure performance of civil infrastructures. Also, study of the iteration of processes and development of advanced inspection and monitoring techniques in order to enhance the durability and safety of buildings. Another specific objective related with this thematic strand is development of urban management models to establish a financing system of urban rehabilitation and public investments improving flexibility and efficiency of existing transport network infrastructure. And another objective, which is also related with my field of research, has to do with rehabilitation of natural and transformed water bodies, such as rivers, lakes, reservoirs, groundwater, aquifers, and so on. Some of the main research areas which are in line with these thematic strands are rehabilitation of concrete and masonry buildings, which has to do with repairing, rehabilitation of damaged masonry buildings, rehabilitation of concrete and steel bridges, which has to do with development of new solutions, retrofitting and rehabilitation of techniques to improve the robustness of bridge structures and resilience. Another research areas has to do with the rehabilitation of and restoration of rivers, mainly developing models, structural and non-structural measures to reduce the impact of let's say hydropowers, of intervention done by humans, such as dams, embankment, gravel mining, damming, and so on. Another area has to do with rehabilitation of roads, airports, railways network by developing models and effective solutions to improve infrastructure, accessibility, safety, pavement preservation and rehabilitation, and also to increase the lifespan of the structures. And last but not least has to do with urban rehabilitation. Rehabilitation, also preservation of built heritage and urban areas, integration of compatibility and coordination between different sectors in this area. Type of research developed within these thematic strands include experimental studies based on large scale and small scale in laboratory works. Also field observation, such as testing the effectiveness of some prototypes developed in our research center, for example, fish shelter against hydropicking, and also numerical modeling such as habitat modeling, fish waste modeling, modeling of behavior of structural elements under different loading conditions. The research developed within these thematic strands contributes directly in seven sustainable development goals under the United Nations Agenda of 2030. Some some research projects, some examples of research projects which are in line with this thematic stance are EcoPic for fish. It's an integrated approach to support self-sustaining fish population and downstream hydropower plants impact. Another project which is associated with this thematic strand is RISCOday'2023, which is seismic rehabilitation of old masonry and concrete buildings. Another example is the shelter project, which has to do with structural hyper-resisting element for life-threatening earthquake risk. Hyperslab is another type of project which is also related with this thematic strand. And about people, of course, not all people at CERIS contribute, the work that they develop contribute 100% in this thematic strand. Therefore, we have organized in 4 quartiles, or we have categorized in 4 quartiles. So, in this case, 41 people, only up to 25% of their work contributed this thematic strand, and 45 for 45 people, only between 26 and 50% of their work contribute in this thematic strand. And only 10 people are very closely related or linked with these thematic strands, which most of their work contribute in this thematic strand, or is in line with this thematic strand. About some future and ongoing activities, of course, we always are trying to disseminate the research activities and projects and other things that are developed in our center in different sources, mainly such as media outreach among different stakeholders, industry, policy makers, decision makers. Also, some of our members very often are giving opinion in media about different pressing issues like droughts, floods, and so on. We are so organizing and also planning webinars and also on-site events related to different topics following with this thematic stance, such as building rehabilitation and energy efficiency, emerging construction materials, river rehabilitation and restoration, nature-based solutions and sustainability, conventional and non-conventional energy storage solution. Another topic that we are planning to invite people to make presentation is related to application of artificial intelligence and digital twin in built and natural environment. We also are trying, especially after the COVID, it's very important to socialize people, and we are trying to foster the interaction, the collaboration among our members, but also with people from our research centers or universities. So this is all about this thematic strand, and thank you very much.
Thank you. That's a really good.
Perfect. So, good afternoon. Instead of bringing, well, it's research, in fact, but it's also our playground. At least we have a lot of fun doing some research at the Monastery of Batalha, where we try to apply some of the things that we are developing in the department, and also in collaboration with other departments, in particular with the physics department, and also from the design and technologies. So in the last years, we have been working in the Monastery of Batalha, trying to apply different technologies. We started with visual inspection, vibration assessment, structural assessment, automatic monitoring and inspection. And nowadays, we are trying some technologies and to apply them in the conservation and restoration. So our main objectives for the next years will be related with, first of all, with some monument characterization, basically geometric survey, trying to do some pathology survey also, and non-destructive testing. using some structural health monitoring in this first stage with some optical fiber sensors, measuring mainly cracks and temperature for now, and also, like Guillermo already presented, using 3D printing to prepare or to develop some missing elements, and also to digitalize some artifacts and using virtual reality to these artifacts and to some constructive elements. And in the end, our main aim is to set up everything in an online dataset platform that can be used by different users. So I will show only some images of what we have been done. So in the first, the monument characterization, we have been performing a geometrical survey, mainly Inés doing her PhD work, doing the survey of the monument. In fact, if you know already the monument, you know that's quite huge. So at the moment we have more than 300 scans. It's not completed. The objective is to have, of course, the online dataset platform with the geometry of the monument, to also correlate with the pathology survey, to support the numerical analysis, and also the structural health monitoring system. So this is an ongoing work, not too much research, but a lot of work that give us a lot of information for the future. Then the next point is the structural health monitoring. In fact, we start, I would say, 5 years ago, trying to monitoring some cracks in one of particular dome, and we can see here 3 techniques used at the time. So topographic measurements, some analog transducer, and also fiber optic sensors. The goodness of the fiber optic sensors is that you cannot see them installed, and in fact we have a lot of sensors. So in this new stage we decided to implement a few more in collaboration with the physics department. We are using a common technique which is a fiber Bragg grating sensors. They cannot be seen, at least they are most invisible. They are immune to electromagnetic interference, they are flexible. They can be many sensors in the same fiber, and they can be used in the monuments. You can see here Inés and Luis installing some of the sensors in this crack, and you can see the crack and you cannot see the sensors. Only with a detailed picture you can see, at least with some detailed look, the presence of the sensors. So this is quite good to install in monuments that are frequently visited. Also, we have been done the monitoring. I will not show in detail. Well, we are looking for trends. In this case, we have no trends or no correlation in this crack with the temperature. We can see here already a deformation around 0.3 millimeters, which is not insignificant in 4 months, so we keep monitoring this crack. In some other places we see 10% of this movement and a clear correlation with the temperature, so this is not so significant, and we keep monitoring and in fact increasing the sensors network. Another area, I will just skip this one because lack of time, but the 3D printing that Guillermo already showed, our main idea is to try to find some elements that are missing, and in fact we can try to replace them with some printed elements. Well, one of the main issues is all the ethical issues, to add elements in some heritage sites, to reproduce the missing elements, to embed sensors in these printed elements, to study the materials that can be applied, and also the connection between the old and the new elements. And like Guillermo already showed, we have started this with some cube, and we are evolving now to the new shapes, and hopefully until the end of the year we will have the first more complex shapes printed. And in the end, this is a side project developed also with a research unit of design here in the university, is the use of augmented reality as a tool for cultural sustainability, not so focused in the construction. Well, we are using 4 artifacts, but also 4 elements in the construction to explain, to pass the knowledge about this. We are using here a structural light laser to develop digital elements, and then with the support from the design to reconstruct them as they were, or based on the images that we have from the past,
on the information from the conservation people, what we can rebuild and add information to these artifacts and also to the construction elements, so we can participate in the education campaign that they have, or in the education department that they have also in the monument. And in the end, in the next steps, well, we will continue to explore these areas, to start a numerical analysis. Hopefully, I hope to have another PhD student working on this topic until the end of the year. We will increase the sensors network with accelerometers, tilt meters, and others, and we keep hopefully achieving the online digital platform with all the information. Well, and that's it. Thank you for your attention.
Thank you, Student of RISC, Ricardo Martins, Manuel Roques, one of our researchers at RISCO.
Just checking if the presenter is working. Is it working? Yes. So my name is Ricardo Martins, and I think I misunderstood a little bit, and I'm doing more of a technical presentation than the previous presentations. I'll try to speak a little bit of everything else that I'm doing, but the main focus will be the presentation of this work. So I work mainly in dual drainage, and why? First of all, the usual suspect, climate change, and because combined sewers are mainly what we have in our cities, developed or not. Dual drainage, which is the consideration of both the flow on the surface system and on the sewer system, is often neglected when designing new drainage systems, and this is often a mistake, because we really need to start considering it, especially because our codes imply that there is a limit return period, and above that often the companies that do the design of the systems, they are not responsible and they don't care about the consequences. In this work, I'm going to focus a little bit on coefficient energy losses and polluted transport that is often neglected in these situations. When we have combined sewer systems, then we have a lot of sewage that can be ejected to the outside and to the streets, and then we have health problems. So, since in Portugal we have a small facility, dual drainage facility in Coimbra, but the surface system is not as big as necessary, so I had access with some other colleagues to a facility in Sheffield. This dual drainage facility is a scaled model. It's a conceptual approach, has a surface system and a sewer system, and it's built modular so that everything can be changed, the sewer position and the manhole position. It is assumed, the transition element between the surface system and the sewer system is assumed as the manhole. Sometimes it is assumed in models, this sort of simplification. It is instrumented with flow meters, pressure transducers, it has turbidity sensors, it even has some cameras and two PIV systems, one 2D PIV system for the surface and one 3D PIV system for the manhole, and it has controllable inlets and outlets. So we wanted to test what was the influence of several street profiles in the flow exchange, in the energy losses, and in the pollutant transport. We tested 5 configurations. The first one is simple street. The second one, it had parking lots on one side, parking lots on both sides, with 2 cars, 2 obstructions, which often pose some, they interact with the flow, and the flow is changed due to that, and when the manhole is skewed to one of the sides. These are photos of the facility. If you want, I can explain after in the coffee break why the photos are green. So we calculated the mass balance basically using 2 flow meters. We had the flow inside, the flow that goes outside. There was no flow on the surface, so we just had the exchange, the part of the surcharge. We calculated the energy losses through the regular discharge coefficients. Usually in the wall drainage, we consider either the orifice or the Weir equation to account for the exchange of flow between the surface and the subsurface. The energy loss was calculated based on localized losses using Bernoulli equation, and the pollutant exchange were calculated based on a percentage, and it was the amount of pollutant that got in and compared to the amount of pollutant that got out. So the coefficients were approximately the same. This was one of the interesting conclusions, that the slope was the same for both the wide street and the narrow streets. When we made the street shorter, the coefficient decreased a little bit. The energy losses were relatively the same. There was no big surprise. The only big surprise was when we got a little bit excess of energy loss from the inlet to the outlet. That was maybe because of the increased water depth on the surface. And the pollutant exchange, although relatively constant throughout the whole exchange, because we have exchange rates from 0.02, well, 2 liters per second to 3.5 liters per second, it's approximately the same, but there is a slight increment in the percentage of pollutant discharged. So this was a high complex, although conceptual, it was a high complexity approach. There was indeed a relationship between the width of the surface and the resulting discharge coefficient. The sewer to surface energy was relatively unaffected, and the pollutant transfer was relatively interesting in that it increased a little bit. Thank you.
Strand 4 related to societal challenges and sustainability.
Good afternoon. My name is Clara Ferreira, and the coordinator of Thematic Strand 4 is Professor Manuel Pinheiro. So today we face pressing challenges associated with natural and societal changes, and within Thematic Strand 4 at CERIS we try to develop solutions that answer those challenges that are very urgent. So this is the outline of the presentation. And starting with the objectives, I would just highlight the main objective of Thematic Strand 4, which is to promote a transition from a condition where we always act in the same way, where it's all business as usual, to another state where the sustainability of the built and natural environments are the main drivers of every action. So this is the main goal of Thematic Strand 4. So to fulfill this goal, we have three main research areas. The first one is to understand the complexity of natural and societal changes, and this involves local to global scales. Then we have the second main research area, which is to improve governance, seeking better integration of policies, new flexible planning and management tools. So we have to develop strategies and principles, and always regarding the sustainable use and management of natural resources. The third main research area involves enhancing the tools to respond adaptively to natural and societal change, and that involves developing flexible strategies, adaptation and mitigation strategies. Within this thematic strand, we contribute to the United Nations Sustainable Development Goals, at least to 7 of those goals, and that contribution is reflected in the multiple research projects that are framed within thematic strand 4. So to present some of those research projects, I would start with the Success project that actually involved researchers from Aveiro University, so some of you may have been involved, and this project analyzed shallow geothermal systems, considering all the factors that within a building are involved in these systems. Then we can also mention the TWIST project, which is a large international project, and CERIS was involved in the Urban Lisbon Living Lab, where wastewater management was considered, trying to develop green walls that treated wastewater through vegetation. The MIST project was already mentioned by my colleague Marta Cabral, because as thematic strands are not closed, some projects may touch different thematic strands. So in this case, it involves the use and management of a natural resource. Then we can also manage the RISE project that actually involves ITECONS, which is now CERIS, the Coimbra CERIS hub. And within the RISE project, prefabricated elements were developed with high value and integrating agro-industrial byproducts. We can also mention the BICLA-R project, which was developed at CERIS with Transportes Metropolitanos de Lisboa. And within this project, a tool was developed to try and prioritize investments that promote the use of cycling transportation. Then we can also mention the Orto Aqua Salutarum project, which the PI was Professor Dídia Covas within CERIS. And within this project, the water management from gardens of the 16th to the 19th centuries were studied to try and understand how those that water management efficient could be reflected in today's systems of water management. Within thematic strand 4, we have a lot of researchers from different areas, these statistics that we present there, the percentage of association of researchers, was a voluntary questionnaire that researchers answered, and I think that some of them are more involved in thematic strand 4 than they think, so this is like, it's not a closed percentage that we present there. So hopefully some more can join our work. Within the next activities of thematic strand 4, we will promote a set of at least 4 webinars, and the first one is already scheduled for the 1st of June, and I hope you can join us. It's about decarbonization, so hopefully you'll receive an invitation soon. And within thematic strand 4, we also try to promote the interaction between researchers from different research groups, but that all work within thematic strand 4, and hopefully we will try to prepare some applications to national and international calls. So that's it. Thank you for your time, and there are contacts if you...
Now we have Carlos Coelho from this area also, sustainability.
Good afternoon to everyone. I will present the work that our group is developing about coastal and port engineering. Of course, this is the result of a group of researchers and PhD students, and later you can see some of the posters that they did. We have 6 posters related with this topic. Today I will speak about coastal management. That is all related with the line of risk, but also risk of coastal erosion, but also looking for a sustainable coast. So I will start my presentation with 3 ongoing projects that include some of the areas that we are working on. Well, one of the projects is INCA that just finished last Sunday, so in the end of April, but also Coast for Us and Across Coast. INCA, Integrated Coastal Climate Change Adaptation for Resilient Communities, is a project that was coordinated by us, but involved also the Environmental Department of the Aveiro University and the Faculty of Sciences of Lisbon University. Includes a lot of participatory approach, including social perspectives and also cost-benefit assessment, and improves the way we look to overtopping and flooding processes. At the end, the project aimed to define a coastal adaptation action plan for the study area of our municipality. So we have discussed it with several different stakeholders, from the central government to local authorities, but also looking for academic researchers and also National Laboratory of Civil Engineering, Civil Protection, surf schools and other local community. And we bring all of them together to several different workshops to discuss what we want for the coast, looking different goals, for instance, physical goals, if we want to reduce the area that we lose due to erosion, or if you just want to avoid overtopping and flooding, or protect urban waterfronts, but also looking at economic point of view for break-even time, or higher valorization over time, or the relationship between benefits and costs. And we also look for different temporal horizon of analysis, just short, medium to long-term analysis. And so, depending on that, we discussed what would be the adaptation pathways along the time to have the municipality of Ovar with a plan to 2100. We discussed the uncertainties related with the forcing agents for the future, also the coastal process, hydrodynamics and dynamics, but also social component, political conditions, and economy. And depending on that, we defined this adaptation pathway with some measures that should be taken considering the development of the coast, and see for different places we can have different interventions along time. At the end, this project, the main results are a very complete website where we have all the information produced by the project. We have 53 different measures to apply in the coast, considering positive and negative impacts in the area of the social impacts, environmental impacts, economic impacts, this kind of sheet. We did 3 participatory workshops, and the final seminar we produced 25 different sheets for cost-benefit assessment in different intervention scenarios, and we have a book with the adaptation plan for Ovar. We have also Cost for Us project. We are trying to apply the Cost tool that was developed during a PhD thesis here at the Aveiro University. This is a project that is led by R5 consultant engineers and also includes R5 Marine Solution, that is a spin-off of, that was produced after the PhD. And we are trying to test different shoreline evolution scenarios and discuss cost and benefits definition methods. So the tool is Coast, that has 3 models, and we are applying this tool to 3 important coastal stretches where we have important erosion rates. We did projections over time for a time horizon of 20 years. We simulate several different intervention scenarios that include new or reshaped coastal structures, but also removal of coastal structures, and including also artificial nourishments of sediments. Those scenarios were defined together with the coastal municipalities and the Portuguese environmental agencies that are in charge by the coastal interventions. This is just an example of different scenarios that we did for the Aveiro coastal stretch. So if we do nothing, we have these losses along the different beaches in the Aveiro region in hectares. And if we do some of these interventions, we can reduce the erosion or gain some territory. And these areas will then be transferred to a cost-benefit assessment. Finally, the across coast. This is again a project that is led by the R5 companies with University of Aveiro and also an Iceland company. The case study that we have there is in the Netherlands, and here we are trying to put the coast tool in the international market, but also we are trying to improve the cross-shore features. So we are working with very simple models, and we have the shoreline evolution model that doesn't consider transversal coastal processes, and we are adding a simplified model for cross-shore process that includes overwash, dune erosion, hydraulic sediment transport, and sediment transport between the bar and the berm. And this will improve our capacity to better discuss artificial nourishments, namely the position of the nourishment in the cross-shore profile that Portuguese Environmental Agency is always doing to us, where to put the sand, where's the better results. So we did already some work on this, just comparing 2 different cross-shore numerical models, discussing the sediment transport formulations, bed friction formulations, coefficients, and the acceleration factors. And so those are preliminary results. And just to finish, some highlights of the research we are doing. So we are working mainly with simplified models to project behaviors in a medium to long-term horizon. We are working in a very different areas. So we are working with people from the economic areas, from social areas, for participatory approach with environment department also. And our research is mainly research that improve our capacity to answer for the questions of society. So it's applied research, and resulting of that, different consultant projects that we have ongoing. So this is my presentation. Thank you.
And now the final presentation is also a researcher, our director, and also linked to this sustainability area. And we are in time, so don't worry. Okay.
Okay. So just to finish off, I picked 3 projects also. They're more of experimental nature, and they use, I would say, real-scale facilities and real-scale testing. So it makes it more interesting when you're working in this field of building physics and building technology. So These projects I will show you give some contribution, partial contribution to the green transition in construction through building technology components and through materials. So everyone knows what's the trend that we have to reverse. This is the trend we have to reverse. From 2015, from the Paris Agreement, obviously there was the opportunity to level off emissions, and we can see that we're not flattening the curve. Obviously population will grow over time. We'll have obviously the need for more construction, more floor area, but emissions and energy keep on growing, so we're not really achieving this goal of flattening these curves. Even with the COVID-19 in 2021, we still obviously dropped a little bit on the CO2 emissions, but we're picking up very quickly. And we're picking up so quickly that there's a study done by the Global Alliance for Buildings and Construction that gives us basically a linear, I would say, trajectory to zero carbon building stock by 2050. And we can see that we started off more or less okay, but we're 9 points under what would be the path to a neutral carbon building stock. So we're not achieving to lower emissions and to lower energy consumption over time. So these are real numbers. This global building tracker indicator has to do with the building codes in different countries, has to do with the consumption profiles, has to do with the energy, renewable energy and harvesting of energy. So there's a lot that comes into play in this index that we call Buildings Climate Tracker. And we're offset by, I would say, 50%. So the main challenges in the construction sector, amongst so many, are the lack of skilled labor, our role in obviously decarbonization of the building and the economy through green jobs, the digitalization, we talked about this, and the circular economy. We have tools, we have answers for this, but I would say everything goes through two challenges. And the two challenges I think that we have to effectively get to a trajectory towards zero is through design challenge and through materials challenge. And that's, I think, the only way we can get to carbon neutrality. So there's a part of this problem that we can solve with smarter design. This means that we can easily reduce 10% with less over-design. We can reduce up to 25% if we obviously have to in account sustainability principles when designing buildings and refurbishing buildings. And if we don't do business as usual, we can go up to 50%. So part of the answer goes through more intelligent design. And the other part of the, I would say, the answer would be through materials. And through materials, we have to shift the paradigm in the construction value chain. And when we talk about materials, we're talking about an alliance to low carbon materials, okay? So we have to incorporate construction demolition waste into novel materials. We have to track down LCA, we have to track down what would be the carbon footprint at everything that we do in a building. We have three drivers for change. These are the three drivers that Europe is investing on: the circular economy, carbon neutral solutions, and the prefabrication, which is something that will be in the near future, I think, one of a major player. Because when we think about a building, the building operation, we will not save too much in terms of operational costs, but we can save a lot of money, and we can save obviously a lot of carbon, or basically reduce a lot of embodied carbon in the first stage of a construction and in the last stage of a construction. So numbers tell us that we can reduce about 40% of embodied impacts in the first stage, and then reduce up to 70% in the end of life. Taking into account that we have the same energy consumption in use of buildings. So the first project I'll show you is a project that has these industrial partners. These industrial partners, it's quite curious because one industrial partners sells blocks, and the other one sells a prefabricated system. Okay, so it's heavyweight and lightweight. And actually they came together, and we have an experimental setup, I'll show you in a moment, that compares exactly two real scale constructed cell tests, okay, with the same conditions, same geometrical conditions, and the same thermal conditions, okay? And there was no problem in comparing them because we had to understand exactly how lightweight construction, okay, if it's wood, if it's LSCF, if it's other type of lightweight construction, compares with the massive construction. So we built these two test cells. You can see there the LSCF test cell and the hollow brick masonry test cell. So the representative, I would say, of a lightweight construction and a heavyweight construction. And you can see they have the same thermal properties, the line at the end. So they're totally comparable. We measured them, and so they're totally comparable. Obviously, dynamically, they're not the same. What we did was we monitored them over 1 year, and we understood, very interesting, that there was not much difference in terms of thermal behavior of these two test cells. Actually, in the winter period, we can get more out of lightweight construction, okay, when we have more sunny days in respect to massive construction. And we also understood that with some principles of ventilation, we can also, okay, tackle the issue of overheating in lightweight construction. So what we can see here is that on an annual basis and a daily basis, it's quite different when you compare an annual basis and a daily basis. Annual basis doesn't really look very different, the green plot and the blue plot. But when you look at the daily profile, you'll see differences by hour of the temperature inside the test cells. So we understood here that LSF can be advantageous if we take into account, for example, the way that we live in buildings, which is we cool and heat in an intermittent way, okay? We don't heat continuously, we don't cool continuously. And that's really important because the way that we live in buildings, we have to think about exactly how we want to construct them. And if we know that we live inside buildings with this type of schedule or with this type of living conditions, we can optimize what is heating and cooling strategies with the type of building fabric. It was interesting to understand that besides temperature, we also monitored energy that was consumed for different heating profiles. We had an intermediate heating profile, and then we had a continuous heating profile. And you can see that in every situation, the light steel frame construction or the lightweight construction consumed less, okay? So this was the first thing that we wanted to demystify because people think that lightweight construction, obviously you will consume more energy, okay? In the winter period, this is obviously not true. In the summer period, we're tackling this now, actually, it's ongoing. And obviously we're waiting for some overheating, obviously in the lightweight construction, but we have an installation for ventilation to see exactly how much we have to ventilate to overcome this overheating. A second project I'd like to show you because it's experimental has to do with it's an FCT project that will finish in the end of 2024. It's on the development of a novel radiant floor system that will be used for cooling and for heating. Okay, the novelty here is that we want to incorporate byproducts from the pulp industry, from the steel industry. So we're incorporating, I would say, these byproducts that the industry doesn't need. You haven't told us about this in this presentation, and mixing them up with other smarter materials like phase change materials. So we can take into account more thermal inertia of the building fabric. And this is a tendency that will be followed because what we call TABs, so the thermally activated building systems, is that the structure or the building itself should also have a role in the climatization of a building. Okay, so we can use building materials, obviously, to help, I would say, damp temperatures inside indoor spaces so we don't have to use so much energy. So we have a big experimental setup. It's not here at the university because it's quite big. We don't have space for this. We have 7 floor slabs. We test 4 each time. Okay, there's slabs that have 1.5 meter by 1.5 meters. We monitor them over time with thermal imaging. We have sensors inside. We control water flow because it's a hydronic system for cooling and for heating. And what we understood is that this novel formulation for the floor screed, if we incorporate these byproducts that are more conductive, so they're more responsive, and with the phase change materials that have this ability for giving more inertia, we can see that that green line maintains more or less between what will be the surface temperature that I want for radiant floor systems, okay, in respect, for example, to other formulations on the market. Obviously, there's a lot to optimize here. We have to optimize control, we have to optimize layers, geometry, water flow, but the idea is to try to tackle all these issues in terms of materials, in terms of control, and obviously in terms of layer distribution. And this obviously numerical simulation will help out because we know that walls, ceilings, and floors will have different coverings, and the covering will have an influence, will have an impact on the way that these systems will work. Because we're talking about gradient system for floors, but we can be talking about walls or ceilings. That's something that you can find in Northern European countries. And the last project is something that's still ongoing. It's in the middle now, and it's very interesting because the partners we have here, not all of them are here, but these are the ones that we interact most with, because we're developing a system or a construction system that's totally dismountable, that's censored, and it will be used, for example, for hospitality reasons. Okay, the idea behind this was the development of a prefabricated system to obviously to shelter elderly. Okay, because we know that population is aging over time, and we have to decentralize what our system is in terms of healthcare. So we have to have infrastructure for this. And this consortium is very big, but we're partners in one of the sub-projects. And one of these sub-projects, we're developing the system with these players, Sonai Aruco and IKEA, and developing this system that has no bolts or screws. It's a prefabricated system made out of timber fiber materials, and it will allow to be totally dismantleable, and you can incorporate building systems into it, okay? So the idea is this system here to go up to 2 floors and be totally dismountable and be censored for temperature, for relative humidity, for vibration in the case, for example, of someone falling, leaks, gas, and the incorporation of these printed sensors into the structure in strategic areas of this prefabricated system. And just to finish off very quickly, we have, in the sequence of this last project, we have this PRR project that will start. It officially has started, actually, but we haven't the team totally on board. Next month we will have our team totally on board. And just to give you an idea that here we have, besides this PRR project, Ilians, we have other projects from other colleagues and other members from RISCO. And this here is very interesting because it brings together passive and active systems for a better built environment. So that's what I would just want to share with you. Thank you very much.
So we have finished our presentation time, and it's time for a debate. And I have one question, because I'm a lazy chairman, so I thought, what is the question I can make everybody to speak? That's the best question, the $1 million question for a chairman. So, and what I thought is that we have to say 2 things. First, I enjoyed very much the CERIS presentation. Thank you for your effort from the different thematic strands. And I'm also very proud, allow me to say, from our RISCO researcher presentations, very updated, and showed something that is very sensitive today, is the ability of the unit to relate with public and private partnerships. And this is very important for us in what you have seen in this different work. And this is clear, something that we are very proud of seeing in our research team here in Aveiro. This unique characteristic of easygoing relation with either public or private, and also international and national, with international and national origin or related projects. So this was very important. So we know we were unfair with some RISCO members because with today and tomorrow RISCO members, because we had to divide them between today and tomorrow presentations. so we have not seen them all, but we have created this opportunity in our debate, which we have here sometimes, in order for them also to intervene and speak about their work or questions or ideas that might have come out when they've seen the CERIS presentations and the thematic strands presentations. So my unique question, I don't know if it is so right, is for what you have seen here, thematic strands, CERIS and RISCO researchers, the ones that have spoken, but especially those ones that have not intervened today, but that will intervene tomorrow. From what you have seen here, these other presenters presenting, either from CERIS, either from RISC works, and because we are trying to foster future collaboration, what would you like to signal out as being interesting and something that you are also thinking or working on, that you could say to the other side, to the series or to CERIS and to the RISCO presenters here, but also works that you have done. So this is a tough question, but from what you have seen, what would you like to signal in terms of this future collaboration? So if you want to just to make a question or say something with this idea of setting up, I'm working on that, so I find your work quite interesting and I would like to be in contact with you. Please stand up and make such interventions. If there is some burning questions from some of you, please do. Now it's the time.
Can I start with a comment,
sure.
please? I mean, I'll stand up. First of all, I'd like to invite João and Inês, that are the vice presidents of CERIS, to join me here in front, because I think they didn't come for lunch, but they arrived. Where is Inês, João?
I don't know.
I know she's either somewhere. So, I mean, they also represent CERIS. They are both, so João Ferreira and Inês Flores. They are from the construction group, RG5, and they are also here to help me to answer questions that may be asked here in this forum. I'll just give some words. I found these presentations very useful. They're quite different, naturally, because this is your RISCO Open Day and you are presenting your research in detail. In our particular case, it was much more difficult because we are a very large center, very comprehensive in areas, and we didn't want to leave any research behind. That's why we brought you just lists of projects and a little bit of what we have done. I found out similarities between your thematic strands. They are not called the same names. I took some notes and probably I'll be committing mistakes. You have safety in construction, probably. We have risks in construction. Risks in construction. We have
your TS2.
Exactly, TS2 is the right correspondence. You particularize in construction. We have a broader scope because we have the hydraulic, geotechnics, transports. So in our case, it's a little bit broader, but you have risks in construction. It's similar to our risk in safety.
But don't take it risk in construction only covering.
I realize that, I know, because, but the name probably would have.
Construction is overall.
Overall, okay, perspective. Then you have characterization and monitoring of built heritage. No.
Conservation and
conservation
of built heritage.
And we have rehabilitation. Rehabilitation.
Similar to your TS.
Similar to ours.
3, I suppose.
3. And then there is another one. What is the last?
Which is sustainability.
Sustainability. And we have the response to society.
And TS1 and TS4, because in sustainability you have also inserted materials, new materials.
Yeah,
and all that.
but we have made a reflection, and we think that product development is almost at the end of all the thematic strands. Is what we produce, is what we achieve. Eventually, that thematic strand, we may rethink a little bit more about it. So these similarities, this is very important. And then I found out as well complementarity between the two centers. From what I've seen, I found complementary, at least in the hydraulic area, in urban floods, experimental research. We carry out lots of numerical research, simulations. We don't have that much experimental. Also coastal management and measures in erosion, because we also do numerical and you have more experimental, and this would reinforce this area. The other areas I'm not so familiar, but I found common interests in the waste valorization and integration of new materials, because we have been doing so, and probably my colleagues can develop a little bit more about that. Building and monitoring and machine learning, we are also working on this area. We are characterizing anomalies, collecting signals, and using artificial intelligence tools to predict behavior. So we are also working in this area. Characterization and monitoring of buildings, we also work on this related to seismic, so I see some synergies. And finally, the green transition in buildings, but naturally this is not my area, and probably I can pass the word to Inês and João, because probably they are more familiar with this.
Well, overall, I agree with Dídia that we have complementarities and also affinities, in the sense that we do similar things, but also different things that complement each other. In the way year to year, we were exactly discussing what will we have to gain in joining or in working together with RISCO. And as a matter of fact, I think that once we have these complementarities and similarities, I think that together we can be stronger than isolated. And I think that's the most interesting feature in joining our teams, however it is done. This is what I took from the presentations that I saw here, was exactly this. So I think it would be a pleasure to join and work closer to you, and I think that we all have to gain with that.
I didn't bring my do not suppose. Okay, in terms of green transition, the combination of passive and active systems is interesting. We have been working more in passive solution, so it's a complementary approach. Also, the large scale monitoring, it's very important, because sometimes we have small spaces.
That's true.
In terms of the lab, so I think there is a good experience
I was impressed
here
with that, the real
in terms of
tests in the
sensors monitoring. We have also some studies, but there are different types of sensors and this kind of approach. And also, I saw also waste. I think we didn't talk about
valorization and integration with new
materials. Yes, we have integrate different types of waste, not only the ones that were mentioned here. So I think it is also a good line in terms of circular economy and blue economy.
Also, I think that the University of Aveiro is very strong in certain more advanced technological areas. I didn't really understood to what extent you actually also work with IT and these areas of electronics and informatics, because I strongly believe that we have to go that path, in the sense that the traditional research in civil engineering is not enough. We have to join these other areas to our work. Today I was giving my first lesson of digital technologies in civil engineering, and I think that we strongly need the help of other departments, and I would like to know to what extent you really do it already, because in technical we are just beginning these relationships.
I think maybe you, Victor, can say some words. We have shown this collaboration in physics department, because we have this facility of physics with electronics to combine different kind of, in the area of sensors and monitoring, in the area of conservation and biotechnology, we have seen Hugo speaking about this, but we have seen also Victor talking about AI and other IoT applications into multi-hazard definition, but also
that involves the relationship with other
softwares and development. I think you have done some work also with that.
Sorry. That involves the relationships with other departments, or just you are
some of
feeding yourself?
Actively, because we don't, I'm supposed to,
Just to give an example, we have this participation in Erasmus project with mathematics and electronics to develop a platform for virtual environment, civil engineering laboratories in a virtual environment. And we made that with a fire resistance laboratory and with a fire resistance test that we have filmed in a 360 camera. And we then, how do we say it, like a movie? We made a movie, virtual tour, and video, yes, and it is now, it will be...
But is it already being used by the students or implemented the platform or not? Or is it
In 1 month, we are finishing the project. In 1 month, we will have this project with, so the other partners provide the seismic test from Skopje in Estonia and from Bochum, Germany, the wind tunnel. So these 3 laboratories that will be virtually in this platform. This is an example.
Okay, thank you. Because actually I think that many times we have knowledge, very important knowledge in the next door that we could use, and sometimes we are too close but we don't interact with each other. Other aspect that impressed me in the University of Aveiro is that you are concerned with the impact, because unfortunately, in my opinion, academics, we are very concerned with our H indexes and how many papers we do and all that, but we forgot sometimes to think, why are we doing this? How important is this for society? So you are focused on that. I want to believe that also we have the thematic strengths, but I think that's also something that we have in common and that we should reinforce, however our relationship will evolve.
And I found very interesting also that you work very close to industry. You have lots of trademarks supporting your projects. And I think this is probably an advantage because of your location. ITECONS also has a very close proximity with the industry. And it's something that would definitely reinforce
I think that was in the, as Professor Real said that in the morning in our meeting with our evaluation committee or external experts committee, that it's part of our DNA in the University of Aveiro. So we see it happen not only in our department, but in other departments. The University of Aveiro was it's doing now 50 years, back in '73, and the first courses appeared because of the industry that existed nearby.
The needs from industry.
Electronics and telecommunications with PT Telecom, and not at that time, the ceramics engineering, materials engineering because of the ceramic engineer, the environmental department, and so on. So this has, from the start of the university, that practically all projects, all initiatives were driven by or sponsored by industry or public partnership. We have seen some municipalities as presented until today. So this has created in our researchers, when they enter the university to do a PhD, or so, it's quite common to have a partner associated to that. So this has created an ecosystem that favors that, and it's not a thing of only one department. It's something that we find in other departments, even in languages and culture. We see this affinity of having an outside partnership for their PhDs or masters, whatever. So this has created quite a way of doing things here in Aveiro, which I think now it's a very positive. We were discussing that exactly as you put it, not only looking at the H index, of course we are going to
That's also important.
we are going to be evaluated by H index. That was our discussion in the morning, but now we have to look into things like how we are valuing the science we are producing for our society, which means our industry, our municipalities, our cities, our partners out there, how we are valuing what we are doing. And this means that research has to be set up in a different way of not, okay, I want to research the shirt color of the electron, but I have to do the research that will translate into society in some way. And I think we are very much into it, and I feel that the young researchers that we have are very much into it, and that's the way we want to proceed. And of course, there is no fundamental and applied research. So there is good and bad research, as someone said in the past. Of course, because we should have fundamental research when it is needed. We shouldn't say, okay, now we are going to do only applied research. That is not the right way to do it. You know, we need to do research driven by what people needs, and if it has to be fundamental, we'll do it fundamental. If it has to be applied, we'll do it applied. So this is the way we think and see science over here.
Also, I think that there is another thing that we should learn from you. That is how you disseminate and how you show things in the social media, because actually you do it very well, and we frequently hear about what you are doing, and in this dissemination we can also see that you do things for society. Of course, that fundamental research is fundamental, it's very important. There is no applied research without fundamental research. But it's important that also you can support society and their needs. And I think that you do that very well, and you communicate it also very well. And I hope we can do that
the
also.
young people here.
Yes.
Not the dinosaurs like me, but the young people here, yes. They are the guilty ones.
Okay, that's a good deal. Congratulations.
I would like also to say that in terms of rehabilitation and cultural heritage, I think there is a good opportunity to boost this area for society also, because we have some concerns about structural heritage, other techniques, but we have to show us another perspective. So I think these two lines can be very complementary in the work of cultural heritage.
Any questions, specific questions?
I think it's not so much of a question, just to say that I've been working already for a few years from a lot of people from SD, Monica, Oliveira, Rita. Something that was very useful in the past was, for example, when we were going after projects, for example, as you said, you know, there's certain expertise that we don't have here, and it exists already there, so that was certainly very useful. You know, when we went after this funding, as I was mentioning, we were going to SD in 2 weeks because of this project that was just funded. But also something that I think is quite useful, even if we don't look at you know, just complementary stuff. For example, when we started doing things in Alvalade, I contacted Rita, and Rita had all this experience, all these master students, all these PhD students that would work in specific buildings there. So we didn't start from scratch, you know, like my students didn't have to spend time doing the basic stuff because, you know, there was like a lot of expertise that we managed to leverage upon. So that's actually something that I'm kind of excited. I feel like a lot of times on the projects, we almost do like all the work like on the last year of the project, or the last 6 months of the project, because we take so much time to do the basics. But for, with the help of the people from Lisbon in some past projects, but also other institutions in other projects, I think we skipped a lot of the basics because we just started, you know, already with all this interesting stuff. The other part that I just wanted to say is because I work a lot on earthquake risk, but I get bored of this very specific field of expertise quite often. And for example, in this other proposals that were successful was because we managed to bring other natural hazards, of course, but then also the energy efficiency and all that stuff. And for example, if I write a proposal and I bring all these aspects with my CV, the proposal will be rejected because I don't have expertise in this stuff. So it was bringing, you know, these other people that are very well known in these fields, and the demonstrator is very, you know, interdisciplinary that I think made a lot of the proposals quite exciting. So that's definitely something that I'm looking forward to work with other people.
Another thing that I think it's important to think about is how we should compete and how we should cooperate. Because actually university tends to have more competition than cooperation. There are things that for me are very strange. For example, if I write a paper with 2 or 3 authors in certain types of evaluations, I have only 1/3 of an article of a paper.
That's right.
And that's bad for me. So it seems that cooperating is not the best way to do things, and I think it is. When we compete, we get stronger, that's no doubt about it. If CERIS and RISCO compete with each other in certain aspects, we may get stronger, but I think we are a very small country, and we should cooperate more than compete with each other. And I think that's the way to do better things in research, instead of doing very small things just to compete with a colleague aside. But that's my view. I have a certain, how do you say, a theory of conspiration that we are all of us working for the Elsevier's and Springers, because we do all the work, we write the papers, we finance the research, we do the peer review stuff, we are the editors, and they get the money. I think we should do better and concern more about our advantages than theirs. And that's why I talked about the H-index and the bibliometry. That's important, but that's not all. And I think we should meditate a little bit about that. Okay. But again, this is my theory of conspiration.
Well, if I just may add, during this session, during this panel, I took here 3 words actually from people that said different things. And the 3 words, and I have some ideas around this with the question at the end: playground, niche, and social impact. This was something that people were saying while they were presenting. And in fact, society in the field of civil engineering is kind of like our playground, because we have the ability of, obviously, engaging with cities, making cities better as infrastructure. So there's so much to be done. So in fact, society is kind of like our playground. And then someone talked about niche, and niche is something very important when you say niche, because that will make you more individual, that will make you more stand out, right? And I think that standing out effectively is something that we try to do in competition, or that comes from competition, but we have to identify these niche areas because they will make us stand out. And then obviously everything after goes after this, right? So we need something to stand out. We need some type of flagship. And someone also said social impact. In every project that we do nowadays, everyone's trying to tell us, okay, but is social impact of your project measurable? Because I'll give you money if you prove to me that it's socially impacting. So research has to convert to societal benefit. And everyone's, when you give you money, they'll ask you for an exploitation project, they'll ask you for an exploitation plan, they'll ask you to measure impact. And not the impact of an H-index, but the impact on society. And this is just a general comment, and I'll finish with a question which has to do, in the opinion of everyone here, what is, in the field of civil engineering, the next step? Is it just looking at what Horizon 2030 is financing and funding? Is it just looking at the new European Bauhaus movement? What's really disruptive? Because that's what's expected of academics, to be disruptive at some point. And what's not disrupting? Is it just disrupting, bringing technology into the civil engineering field? What else, in your vision or in the vision of anyone in the room, would be disruptive? It's a visionary question. I don't have the answer, obviously, but maybe trends or possible trends.
I think one applies to the talk, but against my view on the impact of research. When artificial intelligence began, and I had some colleagues working on that, I was very skeptical. And I told them that this is just a different way of programming, and you are just calling it a very infecting name, but in the end it's just current programming. I was so wrong. If I would measure the impact of a project that they were doing, I would classify it very badly. And we know the impact that artificial intelligence already has and will have in the future. So when measuring impact, also the fundamental research has to have a way of measuring the impact that it might have in the future, and that's very difficult. So we have to be modest and have the idea that this is hard to do, measuring impact, especially when things are to be impacted in a few years and not immediately.
Okay. So I think we can close it for now, but continuing it, because I would suggest you to have a look, for all of you in the room, to have a look for the different posters that we have. We have some collaborators here that have built up these posters. If you have some questions, please do, but do it at the same time. This is the okay. Then that you take your coffee break over there, so we can mingle and talk to each other. And thank you very much for this afternoon. Let's do some networking now.
Thank you for receiving us.
Foi bom, tá bom, tá bom.
Depois
Já comeu os bacalhaus?
mexer. A funcionar, funciona. Eu é que não sei mexer.
ser diferentes. Vamos ver como é que isto se resolve. Eu sei que agora a Dídia vai falar com o Romeu, vamos ver como é que se resolve. Mas era depois da poeira para nós temos mais informação. Porque eu digo, não, e era daí, apresentar coisas. Deixa-me a maratona. Eu demorei imenso para digerir a informação para isto como era tipo 8 minutos e está aqui alguém com quem eu estou logo a ver como isso aqui, eu vejo. E às vezes eu estava a pensar no WhatsApp, eu estava lá tentando olhar para o computador, já não está outra pessoa, já falava outra coisa.
Vamos à frente.